Hi. Hi. Is it working? Is it working? No. Is it working? No. Working? No. It's mute. Is it working? No. Uh, working? Not working. Working? Not working. Hi. 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 Okay. Not working. Hi. Okay. Use this one then. Uh, well, don't know how they design this guy. So then I'm not walking around. I'm just going to. So let's get started. So first thing is to let you know that I have already released the assignment one there. Okay. The assignment one is already on the Blackboard, so where you can take a look. Is be asked to do is to we will have 10 questions, and then each question asking you to explicitly tell you what you're going to do. So download the data, merge the data, do the filtering, and extract data and create histogram, scatter plot, box plot, and calculate the confidence level, and do some resampling and bootstrapping, and to basically just everything that we have done in the class, just basically just try to ask you to redo. Obviously, if you try to put that in ChatGPT, I haven't tried, but probably they'll give the answer. Maybe something similar to what I do or something different, but hope that you try to do it on your own rather than I mean, there's a lot of stuff here, but it's just the same. That's just the way that we do in the class. Okay, so the TA suggests that you would submit both the PDF file or the IPython notebook, where when you do your file in the Cook Lab, right, then you just save the file or download the file as IPython, then and then you can also print that as PDF as well to make things more easy. So if any question, then you can just feel free to ask me or TA. I think you shouldn't have a question because this is something that we do a lot in the class, so it shouldn't be a big thing there. I think we give you 2 weeks to finish, but I think you should take like at most 1 or 2 hours. If you're not familiar with the Python, it may take you some time, but if you're familiar, this will be okay. I mean, you can use ChatGPT. I don't know whether you use it or not, so I don't say anything, but it's better you try to look at your lecture slide, you try before you attempt the ChatGPT. Otherwise, it just you don't take the revision, right? So just look at the answer. It's not good for you, but no one can stop you do anything, right? So that's the first remark. Second remark would be well, actually some of you in this class would ask, right, whether I invest in the stock market, right? And today probably you know, right? And then the comment I have said last Wednesday is I didn't, because maybe casino is better, right? That's what I said. Go to Macau is better, right? In fact, probably today that's proved my point. So that may be more like random walk, but whatever. I do observation that from some of my undergraduate class. I mean, last week has fewer people attending, but this week has more people because I think last week they all do trading, but now they come back to the real world. So well, and the third remark I want to say a little bit here would be that I talked to some of your graduates. I mean, they told last year who took this class as well. I mean, they said the job market is brutal this year. So hope that after when you graduate, the job market recovers. Who know what? But anyway, so hope that the skill you learn from this class can be useful for you to look at the job market. So let's get started. So we are done with lesson 3. I think we have. I don't think we have any leftover from the last class, right? I think we go over everything there, and then there's nothing left to be covered. So I think now we are going to the real stuff. Okay. I mean, first, those classes are review. I mean, I hope you have already remembered many of those. And today, the focus of today will be looking at regression, and looking at how to deal with more complicated things, right? Because later you will see we are focused on single variable regression, right? So that's y and x, and how to explain y based on x. And chapter 8 will be just some transformation on y and x, try to fit it better. Okay, then we'll learn more the multiple regression when you go to in the next class. So the goal is to finish these 2 chapters in the book. I mean, as I said, I highly recommend you read the book when you have time. I mean, if you don't, then it's okay. But it would be great if you try to read the book. Okay. So simple regression. The main focus is on try to explain y based on x, right? And y and x are usually the observation of same individual, right? Say we try to explain maybe say x maybe the time he spent on the website, and y maybe how much he spent, right? So the time he spent may be related to how much he spent, right? If that's the case, then probably you want to keep your audience longer in your website. So that would be one of the idea, right? So the goal is not to explain the individual value, but the average value, right? Because just use x to explain y may be too ambitious, right? Because there's so many things in the world, right, that you can't capture, even though x can be very long. But in this case, you can focus on one. But even if you have a very long x, then there's always something you can't measure, you can't capture. So in the case that we just focus on average value, so that is the thing. And we try to discover the pattern, and then we will try to do 2 different things. And one is the causal analysis. That will be something we focus on the last 2 classes. And then also we can do prediction. That will be, we are going to do it by the end of the month. So we do machine learning is the predictive analysis. And the name, why there's something we want to predict or want to explain, something we care, is called dependent variable, and something we want to use it to explain, to predict, it's called independent. Okay. The name is just because of a classical way in science, right? Right. Y maybe in Chinese would be 因变量, right? And then independent with x would be 奇变量, right? So that would be the name. So the way that in this class, besides we do regression, probably you might know already, but we will learn something maybe new to you if you haven't learned, is non-parametric 非常古籍. So 非常 just non-parametric, there's no parameter there. The reason that because of we want to do this because we don't want to make strong assumption there. Okay. But of course, by making no strong assumption that we really rely a lot on data. And that means that that would be more data-driven. Okay. And probably I explained at the end of last class that actually non-parametric is somewhat related to machine learning. And that is, later you will see that is the tools we use. The first one we call the bin scatter is somewhat very close related to the, say, regression tree idea. Okay, but we will see soon what are they. But actually, we know we have done that when we talk about the management case. I think in chapter 3, I think chapter 3. When we do the chapter 2, I think. When we are chapter 2, at the very last, if you recall, we look at the size of the company and the management score, right? That question, we look at small, medium, large, but we also look at, say, there's a whole scatter plot, right? You still recall that. But we also divide them into 10 different beans, right? And do the plotting. This is called the bean scatter. This is one of the tools. You try to reduce a group, and the prediction would be the Y would be the management score, right? The firm size would be the X, right? And then we group them into different grouping, and then the average of that group will be your prediction. That's your model. Okay, that is something. The first model we will learn today, right? It's the most easiest one, right? Is you group them, or what we call partition, right? You just cut it into different parts, and the mean of those values will be the average, right? That would be the baseline model. And there's the one in the book. I guess that is something is very interesting terminology called LOWES, is locally weighted scatter plot smoothing. We don't give you the formula for that because the formula is very complicated. But we will give you the Python code, just click and it comes out. So that's what we're doing. So this is not the first time we just give you a black box, but there's other black box we give you. Okay. And the second half of our class today will focus on linear regression. So assuming Y and X are related linearly. Okay. And for exponential, quadratic, other form, we'll cover it, I think in the some of them today, but the quadratic or Morse will be on the next class. So this is the thing we want to study. Okay. So as we said, how to do bean scatter is we have hint already in the chapter 2, right? Basically, you group the firm into 10 beans, but it can be more or less, right? And then calculate variation of Y, and that's a model, right? The model is very simple, just group them, and that's it, the case, right? Suppose I have a model, try to predict, say, age group, how age affect your spending, right? Of course, you can run a regression or one different model to explain, but the easiest way is to group your customer into different age group, right? Look at different age group, how much they spend on average, that will become your model, right? So that is we often use, right? That sometimes we call it map weapon, D2 power, right? So we say, maybe we said, right? People from, I apologize for people in Corvallis, people will say, people from Henan, right? You know what I'm saying, right? And people from Shandong, I mean, if you're a woman from Shandong, then, right, maybe something happened, right? So that is something, right? We do that because we do grouping, right? And average behavior from those people, then you would group in certain way, right? You say people from Shanghai would behave a certain way, people from Hong Kong behave a different way, right? Then that is something that that's what we do, right? So this is called bean scatter plot, right? So let us consider the case that we will use throughout this first half of the class. Is called the hotel price data, if you recall that. It's a price comparison website from Vienna. And then we used to clean the data, restrict to 3 to 4 class, 3 to 4 stars of hotel, and price below 6,000. That's what we have done. And so what we want to do today, okay, we want to look at the price, right? And we want to see, try to see if the price with the distance, okay? And the reason we want to do that is, suppose we think that the distance is the most crucial factor for explaining the price, okay? And later you will see we do different model, okay? And if what we found that your price is below your model you predict, then you find a good deal. So the idea is like this, right? Because you, based on your model, you come up with the price, what it should be, right? Of course, the closer to the center must be more expensive, right? That would be something in your model, right? But the fact that if you look at your model and you figure out that, okay, the model predict, say, based on the distance, to predict this price, maybe $200, and you figure out that the price that on the website is like 180 or 160, then that will be a good bargain. If above, then it's not so good bargain. Okay. So how do we build this model? And then we just use as an illustration, the code, we will focus on two different beams, either 2 miles or beyond 2 miles, or you do the 4 beam up to 1, 1 and 2, 2 to 3, and beyond 3. Why 4, 2, and 4 doesn't have to be some special reason. They just do it for illustration. You have to figure out what is the right classification there. Okay. So the way we do is let's do that. I mean, again, I think this is the slide we've seen so many times. Just download the data from the hotel. Let's do that. Let's open the code lab, and then we continue our journey that all the way there. Let's go down. Okay. I think we've done this. I think now we have chapter 7, right? And then we're doing the hotel case, right? Hotel case again. Okay. Okay, this is data. And again, I think by now you should be able to understand every single line and explain very well. If not, plug into the ChatGPT and ask him to explain to you. Okay, they give very nice explanation. After that, then let's continue. Next slide is we have seen already, right? Just to filter, focus on hotel and look at the city and focus on the stars, and we remove no star and focus on price is less than 600. Okay, so that is again, this is something that I don't think we need any further explanation. That's done. Now the next is what we're going to do is look at within 2 miles. Okay, so what I do is do the MP where, which will look at this, look at each row, look at distance. If less than 2, I call it close, otherwise call it far. Okay, I think that is trivial because it's close and far. And then what I do is I put in categorical data. So I declare this one we call it to be categorical variable of this guy, and the category is based on the category I have, right? And then I will look at because it's 1 and 0, right? I just call it. Then that's how I do it, right? And then this is a bunch of category. I hope this is again shouldn't surprise you that much. Okay. Now I'm done. I have 2 categories, right? Maybe I wait for 10 seconds, as I said. And this is already done. If you haven't don't understand what's going on, ask ChatGPT or look at the video recorded for our previous classes, then you can see we have detailed explanation what we have done for this one. Okay. So now what I'm going to do is I want to look at the data, okay, and I want to group that the mean, right? So what I'm going to do is I group them by distance too, which is close and far, right? And in each group, I want to calculate the E expected price based on 2 categories, right? I look at the mean, apply the mean to the price, and I reset the index. If you don't reset the index looks weird. But just at the end of the day, I want to look at the group mean, right? Because I want to look at close and far, right? And look at all the close hotel. I look at the mean of the prices, right? Because that is our model, right? Because this is our model. Do look at, although it looks stupid, right? This is our model, okay? So this is our model. Our first model is here. Let's run it. Yeah, maybe just show the model is good. Let's show the model. Okay. This is our model. Okay. The model is, I mean, you may say is embarrassingly simple, right? Or whether you like it or not, but you say if it is within 2 miles, the price will be $91. If it's beyond, then it's 115, right? So if the hotel is close enough, it's below $91, then it's a good deal, right? If above 91, it's more expensive, right? So this is the baseline, the basic model, right? Although you say it's very stupid, right? But this is already the model we have, right? It's two-group model or two-bin scatter, right? So I guess I hope this would convince you that we have the first model, okay? And of course, you do an assignment as well is I would ask you to create the data, right? So that's why I need to create data frame 1 because I want to create this scatter plot. I guess by now we should be able to explain one by one what I'm doing, okay? If you are not, then you have trouble in doing your assignment, okay? Which I hope you don't, but who knows what. But if you have a question, please ask me during the break. I hope that you understand every single line that we're doing. Okay. And so that's the model. Okay. If you're far away, then 90-something dollar, the closest is this model. Okay. So this is the model we have. Okay. I don't know if you like it or not, but this is the model. Okay. If you want to swap, then probably you want to swap this guy. I think you would swap the order. If you don't like, then you should put the other way around. Okay. Depends on whether you like close is close, far and far, depending on what you like. If you don't like that, you can reverse this force and it depends on how you like it, right? The reason is because you define this as 1 and 0. So you want to follow the order or reverse it. Okay? It's up to you whether you like which one. Okay. Is that clear how we do the model? This is our model, the simplest model, right? Good. So you're happy with our first model, I hope. At least, right? Well, a bit. Come on, this is still good, but that's how people would look at stock market, right? Either the bull market, either the bear market, right? This is how we view the world, right? Binary, okay? So now we have fun. Here is, I want to introduce something that I haven't talked a little bit before, is to add something to the MATPLAB what we're doing. But what we're doing is very basic. And very often that we are not just happy with the points. Let me show you the end outcome here is I want not just the dot, but also want the number on that. But to do so is require a little bit coding. Okay. So how do we do the code is slightly troublesome. Okay. I mean, of course, and when I say slightly troublesome, in fact, look at most of the code is right in this way. So actually the way I roll is a little bit unusual, but this is more standard way to write things. Okay. Usually when you look at when people talk about tutorial on the MATPLAB on the web or what, usually they would define this way. Well, probably there's some reason why you see my code is a little bit different. So they would usually define subplot rather than plot itself. They use a subplot idea. Okay, that means that they have to separate, as you can see, is equal to subplot. Actually, give you two things: a figure and x-axis. So they actually define things differently based on the x and the figure. Okay, and you have to SS gives you scatter plot. Okay. So you can see it's more convoluted. So that's why I didn't talk in this way. But once I define that, I can define the axis, okay, and I give the intonation, which give how I look at the point. Okay, I mean let's give this fun first, and after that I put the label on the plot. Okay, so it's the same as before, right? But the only difference is I have to separate them, and I define x. The figure I actually don't use it anyway. Okay, but this is how the applied one works. So I mean I don't want to comment further. But what I'm doing here that looks crazy, okay? What I'm doing here is I use a for loop, okay? Just to let you know that this is not necessary for you do the assignment or what, but just let you know how this being done in case you want to know, okay? Because it will be important for the next graph I'm going to draw. So I have a loop over zipping over x and y. So what is zipping over x and y? Is to get an x and y, list of x and list of y, and then you take a pair, first element from the list, become the first element. So x1, y1, right? xi, yi, right? So you take x and y, zip it to a list, and then that means the coordinate, right? Then you would just change it to the string, right? Because you want to run it, you get the integer and become a text there. And you tell them where to put the text, okay? And the coordinate is same as the data coordinate, okay? And this xy text is try to offset about 4, go up by 4. And then once you do that, you can create this go up by 4. Okay, so that is the way I do. Okay, now let me show you. Let's do it together, and you will see why this code, right? So there's nothing new here again. You just I define subplot. I separate two parts. One is axis and vector. Okay, I also do the scatter plot. So there's nothing new there. Okay, and you can see if I do that, it's the same, right? But right, same as before, right? But what I really want is to add intonation there. So that's why if I do that, okay, add another one, okay. There's a for loop there, so I need to tap it. Okay. So you can see already the number are there. Okay. So don't worry if you don't understand this thing, this will be there same all the time. So unless you want to change, maybe change this 4 to say 5 or 6, make it bigger. Otherwise, this is this code will be very standard, right? Because you're just telling me that for every data point, you just go up a little bit and then write the y. Okay, this because you just write the y. If you do a bin scatter plot like this, it's always like this form, this code, right? And the rest will be just adding the labels and titles. So there's nothing really special, right? Okay. So that is the code I have, right? So that's how you can see this is the model, right? Very simple model. Is that okay? Although this is super amazingly simple, but the first model, and don't laugh, this is the baseline for a lot of what we call the non-parametric regression stuff like this. It is localized regression or localized mean. Okay. Now, we want to do for bin because 1 up to 2 is too simple, right? We want to have a little bit more fun, right? So what we do is divide into 4 bins, right? 0 to 1, 1 to 2, 2 to 3, and up to 3. We want to do the mean for each group, okay? Okay. And when we plot where to put the plot, right? We want to plot later, or we want to do a scatter plot, right? The scatter plot, what we want to get is like this. Okay. And of course, it's easy to put the plot y, right? But what about x, right? So what we do is the x will be using the what we call the group average, right? Because if grouping is 1 to 0, right? We can put X as 0.5. Okay. The Y will be, the point will be the average within this group, right? And 1 to 2, the average 1.5, that's no problem. And 2 to 3 is 1.5, 2.5, right? But what happened to where to put this guy? Okay. And the way the textbook do is 3 is the boundary, right? And they look at the data, the max is 6.8, around 7. So they put the mid is 5. Okay? So that's what we will do. Okay. So that's what I do. Is you have done because for bin, you have to do it 4 times. Okay. The first time is you would say less than 1, you put 0.5, right? Because 0 to 1 is 0.5, right? If 1 up to 2, then you put 1.5 because put the middle guy, right? And when it's 2 to 2.5, 2 to 3 to 2.5, when beyond 3, you put 5 because the maximum is 7, right? 3 to 7, the middle is 5. Okay, so that is how this 4 bin is being done. Okay, let me copy it and we will do this. This is the code. Okay, the first one put NA, right? So that's how I do it. It's a building up one by one, right? Because you do it in this way, then if doesn't satisfy, you go back, right? Just keep doing. We've done this last time already. Okay, is that clear why this is true? I think we have done this in the before, right? We divide into 3 groups or 10. Okay. Now, what we need is first we need to put a category because we want to group and then group them and then calculate the average, right? So that is the thing we'll do is to declare them their category. I think we have done this before. After we've done the category thing, okay, we do the same, right? We group them because now it's category, you can do it. And then we look at the mean in this group, then this is the model, right? Although this is very simple model, but already we have the model. Okay. So you can see that this is embarrassingly simple, but you can see that especially for distance 0.5, the price is much higher than before, right? Before we have 115, right? If close within 2 miles. But now if we dissect it into 0 to 1 and 1 to 5, sorry, 0 to 1 and 1 to 2, then it becomes more refined, right? The city center within 1 mile is very expensive. Okay, so that means that we're accurate. Of course, the further you divide the groups, right, the number become more accurate. But that limit you can how close you divide, right? Because to get smaller and smaller, then the category is getting more, then it's no more meaningful, right? Because you can always look at data, right? And the thing that there's a limitation of how many groups you can do, right? As long as there's some reason why you group them, right? But this is the 4 grouping exercise, right? I hope that should be all right to everyone. We estimate 2 model already today, right? Just we've done the 2 group model. We have 3 group model. Okay. So here is the we've done that. We just do the subplot, right? I think we have explained this already. How we do that, I just copy and paste without worrying about. Okay. So that's the model. If you want to show people, this is the model we have. All right. If you try to tell me, okay, within 1 mile, if the price is like 100, then it's maybe a good deal. All right. If you just care, the distance is thing you care. All right. If you only care about distance, you just go to the hotel and sleep. Okay. Don't do anything else, right? Don't do spa, don't do massage. Just sleep in the room, right? Then this doesn't matter only to you because you want to visit the city. Then this is the right model, right? But if you care about whether they have a nice bed, nice aircon, they have bunch of other stuff, then probably you would care, right? Whether the pillow is very soft, right? You care those, right? Or you need some people go to trip, then always don't eat anything, always ask room service, right? They have a lot of money, right? Just call, then this may not be the good model, but if you only care about distance, then this is the right model. You can also add that the label, but I'm not going to do that, but that is how you create this table, right? This is the simplest model you can get, right? But already give you that the model we have, okay? The easiest model. Is that okay? Okay, of course, this is amazingly simple, right? So can we do a little bit better graph, because this graph looks amazingly stupid, okay? So let's do a scatter plot and draw a line, then it will be much better. So what I do is I would do a scatter plot based on the original data, right? DF, not DF1, DF is original data, right? So I would just plot the original data. That's what I do. Okay, this is original data, right? So there's a bunch of data there. Okay, and what I want to do is, okay, I want to add the labels title, and then I want to limit the y because make it look nicer. Okay, there's nothing new here, but let's say. Okay, I just make it up to 400, so just make it nicer. Okay, but the main thing is I want, okay, is to draw a bunch of lines. Okay, what I'm going to do is to, okay, declare the lines. Okay, A and B are the starting point, ending point of each interval, right? The first interval is 0 to 1. The second one is 1 to 2. And the third one is 2 to 3. The last one is 3 to 7, right? And for the interval, each first interval is look at the level, the mean of the y is the DF1 expected price on category 4. Okay. Then what I'm going to do is to have a for loop, looping over when it start, when end of the value of y by ABH, right? Because starting point, ending point, and the height. Okay. So then I want to draw the AX dot plot. Then I draw from here to here what's the value, because it's a flat line. So I just draw the same value. Okay. And then draw a line, because draw a line, you have to give them 2 coordinates, right? End point, right? The starting point of X, the starting point of Y, but the Y is the same as a flat line. So once I do that, then this will draw me the red line. Okay. So if I do that, again, I have to do that tab. Okay. Then I do that. So you will see this is the model we have, right? Okay, 0 to 1, 1 to 2, and 2 to 3 is a little bit close, but you can see this is the model, right? So the model, the data we have is blue one. This nice illustrate. This is our model, right? The model is the red. The red is the thing. Okay. So I think the dots are too big. So sometimes if you want, I think we can say the S is 2. I think this will make it smaller. So I put S is here, the size. The dot make it smaller, then you look a little bit better, right? So this tells us the model, all right? The model is being the red color, right? We just, here you can see, right? I condensed the very complicated data, right? Many data points to a model with only 4 different values, right? You tell me which group you are in, my model is the red line. The model only have 4 numbers, right? Very simple model, right? I reduce the dimension of data, right? I think it's more than 100, right? And you basically reduce how much the data I have. The data is like 200 data point, right? I reduce 200 data point to 4 numbers. Okay, so that is our model. Is that clear? So far, we have done with 2 different models. Is that okay? Is that okay? Well, I could actually go to this one, but I will leave it off a break. But what I'm going to do later, you will see at PV what we're doing is this is a little bit there's a discrete jump, right? The model doesn't look good because when you jump from 0.99 miles to 1.01 miles, then your prediction change, right? Not very desirable property, right? So the question is, well, is there any way to smooth it out? Okay. The answer is one of the ways called the Lewis. At the end, we will we'll see that we'll draw this kind of curve to smooth it out. Okay. Or this is at the end we'll draw this. Okay. Looks very similar, but at the end it's a continuous line. Okay. It's a prediction. Okay. But don't worry, you can see the code is not very crazy, but we'll come back after the break and we'll do this black box model. Okay. And then you will see how we fit the simplest non-parametric regression. Okay. So let's break of 15 minutes, and then when we come back at 3:30, then we can continue. But good that you learned 2 models already. So we have 3 models, and then we learn regression. So basically, the main thing we learned this class is 4 different types of model. Okay. We learned 2 already. So let's break, and then in the meantime, you can fill up the you reply, and then if you can tell me how fast, how slow I'm going, then it'd be great. Okay, I'll see you after the break. 3:30.没影响，那个就是有做有的，那就分子给你看的，都是我们算的时候就是你有做有 ，OK， 跟我来放。不，但是你明白为什么你有问题？你没有什么错吧？哦，明白，因为它后面有答案。哦，对，行，对。在半个小时内做。 所以是吧？可以下 GPT。我觉得应该是为什么 TA 会不发在书？我犯错了吗？你们不是 IS 吗？你们是 IT 啊？哎，我们是 IT class 吗？哦，OK，sorry，我怎么 copy 过去呢？我等一等啊，我 copy 过去吧。你们是 IT 的吧？ Sorry that someone told me that I plugged in the wrong file, so I just into IT so you can check it back in case you're not there. Okay.为什么要01、02没有它的数据？一个 mile 传给他，后面的数据比较小，都可以弄。查一下这个数据量，通常当这个都是叫 average， 通常我们就是分点的话，会看一下按照一个 mile、2个 mile、3个 mile， 对，但是你说这个是一个不对平的，这个没有必要。这个是它机制是这个，那个是这个。但如果你不深究这边该对我们的另外一个方法就是，如果是它的需求，它是一个非这个。你要上一期我们做的是 Q cut， 就是equal number of observation 也可以做 Q cut， 10%这样的，前半10%的话，就是按 distance 上的，没有一个 hard and fast 公式。上次你作业已经做完了。没有啊。真的，把这个东西扔掉，有差距定个一下。但是也不用做啊。我也等一下，我会上复原做完会交了。这边呢还有不好意思，我抱歉，但是我既然不能问太难，有很多陆续是，之前做太难，那既然没办法。 大家看到，好像已经差不多。那个，再一个把这个价格上来，结果都是结果上好是这个都说什么跟风铁线的变，风铁线系统天天做到上上去。香港人这些都会告诉大家，因为对，就是后面那个，这个没有，
本来就是可以是跟第一个
对，再来是个，比方说，就在比如说第一同学，
对呀，
天气的。10月份那个还短暂的一个，9月份还是11月的时候还是。
那不是我个人
12月的10月份过年的时候，还有我传后的过年的消息。对，所以我今天有看得到小号，我觉得他们不能穿不是效果的，对吧？只能穿那个对，但是能穿它的好，到底多少还是包括啊？一个18可以小20万，就是还有一个身体14，都可以包的衣服啊。
你快理解你学霸，
8年多，怎么可能？我都不承认，再找怎么去？按照你选读最多的时候，上修，那个应该不需要，基本上。那你那个就太少。那个回到那个，当然说还不能管理。 Oh, sorry, this doesn't work. So I have some good news for you. I learned that some of your classmates already done the assignment during the break. So it means that it doesn't take more than 15 minutes, right? So maybe next assignment I increase a little bit of difficulty. But it means it's not that difficult, okay? So so I think you can finish like 1 hour at most, right? Or 2 hours. I mean, you can finish, someone can finish in half an hour or 15 minutes, then shouldn't take too long. Okay. But congratulations, this will be easy assignment. Yeah, but as you said, I mean, some of your classmates already done, so so I hope it's okay. Yeah, so I hope now the IT class is right? I think I just move it to the IT. So remind me if I'm wrong next time. So, but it's my problem. So, a bit quick. So the thing we work on is just the code is very similar to what we have done before, right? It's just like group them based on the distance, and then carry the mean, and then plot them, and this is the model we have, right? The difficult part is to represent it. You may say I just a little bit brush on the for loop because I think that this is not something too crazy, right? Because it's just like for X and Y, then you just look at the height and where you put the code, but you will use it anyway. And slightly difficult part is this guy, right? Basically, you group them by the first line segment is from 0 to 1. And this is the first group of the expected price, and you just plot them. The only difficult part is AX plot is you call it red color, the line style is dash. But I hope it's not that fast, but if any case. Yeah, nicely to the class. So just to remind you that we will have at least until the end of next 2 classes, we also here. Hopefully we can have the rest, but let's play and pray and see if we're good luck or not. Because it depends on the availability. What else? Go back to the, sorry, I'm just in the middle of looking at your reply. Okay, so far it's okay. And quickly to see, oh, Friday already. Oh, again, we have some of our classmates already in the holiday mood. So already jump to Friday, which is good. Yep, overall, now it's cloudy, that's good. Yeah, regression, we'll do it. Code lab, how to use it. And annotate, visualize, panda, 2, yeah. We haven't done regression yet, but we will be doing that. Will be the most meaningful thing. The speed is okay so far. Not that problematic. I think you get it. What's the brand? I will check later, tell you. I got this from the US, but yeah, they've been sitting in my wardrobe for a very long time because usually I don't wear this one, but I have that. But Slippy, so hopefully with some jokes we are happier. Why our program fee are increased year by year? So what I can tell you is our tuition is cheaper than other school, right? And for the tuition, as an economist, I can tell you doesn't satisfy law of demand, right? It's more like a handbag for ladies, right? If we put the dollar is $1, no one would buy it. If I put it 1,000, then people would buy it. And it also, in some sense, the tuition, the increase of tuition, we have more resources to do more stuff. And basically, say, so for example, your industry engagement project actually costs a lot of money. That's what I know. And I don't know about the finance, but at least we're cheaper than the others. So that's what I can say. And it's why increase year by year? Because we are not allowed to increase once and for all. So you guys are lucky because it will be increasing until we are similar to other school, other university. But we cannot increase big chunk. This is regulation of the school. So that's why you're lucky, not because we increasing, but because of we can't increase in the big chunk, right? So, but you look at CCTV, right? People are happy when they see the price going up, right? 喜情降价了 so that should be happy. Any advice for tomorrow career fair? Yes, we go. I mean, you should go there and dress up. You will see people with dress like a formal suit. Try to see the chance there. Everyone in B school like this. So hopefully, since you are in B school, pass B school degree, so probably you should dress up a little bit if you want to go there. If they do interview, if they don't, then it's okay. Any advice? No, but just dress up, and that should be you should be happy. And as I told you, right now these days the job market is very competitive, right? So it's more like luck than other thing, right? And this networking is most important, right? So I hope you try to contact our previous graduate and see if our office can help you. That is more important, right? And of course, if you do interview, right? I mean, if you try to use our class, right? I mean, that probably you should able to tell them, right? You know, regression, you know, noise, you know, some Python coding. Remember to put Python in your CV because with those so many Python, then you should be comfortable to put Python in your CV and you're ready to tell people what kind of library you know, right? So that would be very important, right? But when you say Python, probably you have to prepare to show your skill, right? And probably you also bring a CV with you, a paper version of CV, right? Get ready for that. Yeah, and practice for 1 or 2 minutes about yourself, right? Tell them what you're doing, what you have been doing, and then that's very important, right? What is a strong point, what's a weak point, and I can see many of you are very good, right? Based on your CV, then so it shouldn't be too much difficulties. But again, regardless of all the job market, is always luck. Luck is more important than anything. Well, good luck. I mean, advice. Another final piece of advice is maybe go to temple after the class and see if you get more luck from the God or whatever. Yeah, comfortable. Yes. Well, if you have luck, then you get in the stock market, you earn all the money, right? As I recommend you go to casino, is faster and maybe more fair because you don't know what, right? Yeah, happy, yes. Sleepy, sleepy, sleepy. Yeah. So, oh, why cry? I think our class is pretty happy. At least look at your assignment, right? Although it looks very long, I mean, but someone has already finished it, right? So shouldn't feel very bad. I mean, should be happier. Especially tomorrow job fair. So bring your smile there. Smile is very important. And remember eye contact, something that I guess as an Asian or Chinese, that is something we didn't teach, right? How to do eye contact and how to smile, right? Not the weird smile, right? Normal smile is very important. Yeah, overall it's fine. So good luck to that. So now we're going to talk about this particular estimation method, right? And it's also in the book, so that's why I talk about that. Usually it's not in the standard textbook. So that's why we don't have formula to put it there. It's a black box technique, okay? So this example we do is we will use the NumPy that's okay with a Matplotlib, and the new package we use is the stat models API. Good. Later you will see this is the model that we often see sometime. And I call it SM. Okay, make it short form. Okay, and suppose I have data, and it's very simple. I just call the estimate model SM, non-parametric, and Lewis, and then Y and X, and that's done. Once I did that, it's already automatically do all the calculation for you, the type one, okay? And then you give you two columns of X and Y smooth version, okay? So let's copy this guy all the way and run it so that you know that it's very simple. And I run this, okay? And you smooth out Y and X there, okay? And then what we will do, okay, is to plot them, right? We'll plot the scatter plot is original data. We plot the line with the red color, you give it this guy, okay? So that would be the thing we want to draw. Okay. So although this looks weird, but you can see I try to have a line that try to plot out, smooth out this irregularity, right? So this is the model we have. Okay. Although the dimension wise it looks weird, right? Doesn't reduce too much dimension. But when you have a bunch of data, then the dimension reduction will be more clear, right? But do remind that when we do a model, basically we just make from the data, we make it more simple, right? So that's what's what we're doing. Okay. And probably you will say, okay, this is something funny. Let me apply to the example that we've been doing, right? So what we get is try to do this diagram, go back to this diagram, okay? So what we do is, again, do the same thing, right? Run the thing called X and Y and put there, right? Run it and smooth it out, right? So I think that is nothing new there, but before the data is given, but now we have the real data, right? So this is a real data and we run it, okay? After we run this guy and we plot it, okay? But let me copy and place and I stop 10 seconds so that you can also work in on your side. So you will see very quickly with the model, right? Scatter plot and the line, but the scatter plot I said a little bit too big. Let's reduce the size to 2 to make it look a little bit more comfortable. So you can see there's a many point there, but we smooth out by the red one. Okay, so that is a little bit weird, right? You do notice that this is not decreasing over distance, which make us query why this is right. because you expect, right, the further away you should be lower, all right, in general, right? So it must be the case either this point or this point are maybe super big mention, right, or something abnormal thing there. But let's keep it what it is. This data will tell us. If you don't like this, you can cut the data, right, to make that more reasonable, right? But at least it captures the idea that it go down, right? And it's continuous. Okay. So that would be the basic model that we're talking. And usually we don't use this particular graph directly. Usually we will try to use this regression to tell you whether you want to run a regression with a linear way or non-linear way, or you want to transform the data. Okay, so that will be, we usually don't use this directly, although some people use directly, but if the textbook they use is not using this directly. Okay? Just telling you that, okay, it's non-linear, linear, you need to include more form. So it will become clear later how we use this one, but this will be usually a checking to show that whether there's something abnormal from the data. Okay. But I hope this is okay. But as I said, if I really want to use this is the thing this is the model I would use. Right, this is the model I think is better. Although there's some discontinuity there, but I think I will use this model. Okay. If I don't want to write a real model, right? If I'm really happy with the non-parametric model, we're not estimating parameter, and this is what we do, what we have. Okay. So no, if you're okay with that, I hope that is not too bad. I want to talk about the main model, which we used at least for this class and next class. It's called regression model. And as the first round, we focus on linear regression, right? Which is try to draw a straight line over a scatter plot, right? And the form we use is called the slope-intercept form, right? This is alpha is being the y-intercept and b the slope, right? This is standard in all the regression model, right? And alpha means when x equals 0, what is the value of y? Okay, usually it's not meaningful. The meaningful part is the beta. It's telling me that, or telling us that if x increased by 1, on average, how y increase. And usually this is the parameter interest. Beta is the thing we care, right? If beta is large or not close to 0, then the model is meaningful, right? The beta is close to 0, the model is useless. Okay, alpha is just not very meaningful parameter. We usually don't care that much. The only thing we care is beta. Okay, oh, I'm sorry that I don't know why the PDF like this, but how do we do the data wise? I'm sorry for the why they go in this way. So it's what we call the ordinary square is minimize vertical distance. Okay, so the idea, look at this graph. Okay, the dots are the data. Okay, and what we trying to do is to figure out different possible lines, maybe here, maybe here, maybe here, maybe there, maybe here. Okay, but there are many lines we can draw, right, to fit. Okay, and what is the criteria to call best? Okay, there are many criteria you can imagine, right? One of the things that people discover or people insist, this is one of the nice thing is look at the vertical distance from the point to the line, right? And in this point, you may ask why this one, right? There are many possible distance. Why I don't look at the horizontal distance or the perpendicular distance? Okay. Indeed, there are models talking about this. I think this is called the ridge regression, which we don't talk about in our course. And so what left is Why vertical, not horizontal? The reason being that we're trying to use X to explain Y, right? So what is the model is explaining predicting is based on X. I want to look at the Y, right? So the distance, vertical distance, is measuring how good your fit is, right? If this vertical distance is very small, that's a good model, right? The horizontal is not relevant, right? Because we use X to predict Y, right? So that is the vertical distance is the error or the accuracy or the problem with your model, right? You want to make it as small as possible, okay? And we focus on this distance, right? This is a line. We focus on square. One of the reasons why we want to do this is the square is easy to calculate if you know calculus. That make our life easier. If you use absolute value, that's another type of regression. Okay, so that is much better why I'm talking in this way. So that would be the model, right? We try to figure out what is the alpha and beta, right? By changing different intercept, different slope, right? And then we want to have that. Is that clear? Okay. And square means that there's no difference between up and down, right? So go up and go down is same to us. Okay. Of course, you can change it, right? But this is the way we do, and this is a classical model. Okay, to repeat is just we're trying to figure out the line by changing intercept and the slope, right? To make the best fit. Okay. And this is called the ordinary least square. This is 所谓的回归. So without showing the proof, actually you can do calculus quickly. If you know calculus, it's multivariate calculus. This is the formula, and this is the formula, and I don't ask for any formula. I just show this is the formula because of master class, right? So just the formula, and turn out to be just try to explain is covariance over variance. Okay. And not surprisingly, right? Covariance is measuring how two variable related, right? So that's covariance. And you may ask why we divide by variance. The main reason is if X has higher variance, the slope is smaller. How can we see that? Look at this diagram. If I have X has more variance, it means that X is more spread out, right? So look at this, X may be more spread out, right? They have same mean, right? You consider another diagram, X is larger, right? Okay. And if you fit this cross as a new data set, then you will be flatter, right? So if you X more spread out, right? So you move all the pawn to the right, right? So just basically what I'm doing is if you try to move this pawn further away, right? This is the mean, you move this to the left-hand side. Okay? And same for the red color. Your data will be more spread out, right? But then the slope will be much more flat. So increase the variance will make the slope less, which is not surprising. Is because of your prediction is not so accurate, right? And the intercept is given by a very simple thing is alpha actually just y bar minus beta hat x bar. So if you rewrite that rewrite this equation, what you have is y bar equal to alpha hat plus beta hat x bar, which means that the regression line always passes through the center of data. Okay, so that means that if you try to think about this is if you have the regression line, it's always the case that the middle of the data, the center of data, will be passed through by the regression line. Okay. So not going to talk more, but this is the slide, and I used to teach undergrad. So this is, you can see this very funny template is the slide I teach undergrad. I just put there because I'm a little bit lazy. So so let's do the regression, okay, for some arbitrary data. Okay, so here I have, as I said, we'll use the stat model. Okay, .api. Oh, SSM. So this I got all the, we have done the lowest, and now we've got the model there. Okay, so I want to explain y based on x. Okay, and the first thing we do is, because I need a constant term, which is alpha. So for some special reason, if you learn matrix algebra, if you learn Juzhen, then we need to add a constant. We add a bunch of one there. Okay, and then we run the regression based on this thing. Okay, this is the model, and we try to fit it, and I print out the summary. Okay, so let me do one by one, and you see what I'm doing. Okay, so we just a little bit slower because some of you tell me I'm too fast, so slow down a little bit. So I guess I can stop up to here, right? So then let's see what x gives us. Okay. So actually you can see I add a 1 to the beginning. Okay. Why I do that? If you learn matrix algebra, that's what you do. Okay. But I'm not going to discuss what it is, but this is required for regression. Okay. And then if you do this line, it's just asking us to run the regression model of y based on x. Okay, it's not a model, and it called model.fit. They will actually estimate the model and store in the result. Okay, and I want to print the result summary. They will give us a very nice output like this. Okay, and the goal is try to make sense what we're doing here. Okay, but before we do that, let us look at why pause it. Let's see. Okay. So there are many things in this table. Okay, and the most important thing is these guys, right? And this is alpha, and this is Alexander color, right? And this beta, right? These are the most important number there. And if you ever do regression analysis, right, the most important thing probably you would try to look at is this column. Okay, and you ever try to hack regression, these are the two numbers that you want to look at. Okay, and what it is the p-value of the hypothesis testing, whether the coefficients are 0 or not, right? You'll be happy if this number are less than 5%. So actually, I'm not very happy because this model is rubbish, right? Because alpha is, you cannot reject, it's from 0 and beta is not, right? Because look at the case we have interval estimate, right? From negative positive include 0. So basically, the model is useless because I can't rule out that this come from something nonsense, right? So this model is crap in other sense. Okay, this is garbage, right? But these two numbers and this number, this is basically the 4 numbers. It's the most important thing you want to look at, right? And all others we'll explain later, but this is the first 4 numbers we look at, right? this is, remember what I'm doing here? This is the H now is alpha equal to 0. And for this one, it's talking about beta equal to 0, right? You want to see whether the slope or intercept are 0 or not. If you can't reject it, right, the p-value is not small enough, then we can't do a lot of stuff, right? So usually we want this p-value is 5%, right? The worst case is 10%, right? Or even 1%, but is that okay? So this is the, when you do regression, this is what you do, right? You would just, when you run the regression, close your eye and hope this number are nice. Okay. Is that okay? There are many things we can explain, but let's do it later. Okay. This is the standard error. Actually, you remember this is we do it in the last class, right? Also come on the formula. And this is how this alpha and beta looks like, right? And this t value will be, you divide first column to the second column will give you the t. Okay. But I think we only need p, right? That is the only thing we need to know. Okay. So more or less, you know, this important result is here. Okay, there are many things you want to look at, but this is the main column you're trying to look when you run regression. Okay, but we go to a more realistic case and we'll go into more detail. Okay. And after that, you want to show your regression result. Okay. And this we will do a lot of time when we do prediction comparison. Is we want to draw a scatter plot and line plot. Okay. And the line plot will present the model represent actually as we did it in the beam scatter diagram or the Lewis, right? So we have the model, we predict it, and then this prediction means what? Give me all the X. Based on the model, give me more prediction, right? This is the regression line, right? And based on the scatter plot, I plot it, and based on the X, I plot prediction using red color, and I label them. Okay, so that would be the model. Let me copy that and run. Then at least you will see what the regression model is doing. So the regression doing is we have 5 data points, right? We'll try to fit the line, okay? And the line is just try to minimize this distance. Okay, there's 4 distance here, okay? 5 distance here, right? And the case is we're looking at different line, maybe here, maybe there, okay? Maybe different lines, but this, the one we have drawn, the red one, the deep red one, is the one that minimizes the vertical square distance sum of. Okay, so this is the best fit line. And you know the formula, but of course, Python do everything for you. So just need to know what we are doing, right? And that would be the case we have, right? The regression. So the immediate thing that we want to do, this is the line, right? Is to find a good deal, right? Remember our original story, right? Is look at the good deal, right? And what we're going to do is to go back and plot this diagram. Look at hotel, data, and plot the line, okay? And you can see at least why I cannot here, right? If we draw this diagram, but you will see this is not a good deal, it's a bad deal, right? And if these are good one, okay, this red are good one, but what will be the best deal? Maybe somewhere like all the bottom guys are the good deal, the orange, okay? Depends on the distance you actually want to go. For the orange, those are pretty good ones. Okay, this is the way that we find good deal based on the model, right? If the only thing you care about distance, okay, you just care about distance, then the orange are the thing that you should consider, right? Because on average, you should on the green line, but you're getting a good deal if you go to the orange thing, right? You should look at the red one. Non-red one, you should ignore because they're more expensive, right? Of course, you will say, okay, I don't care only the distance, we don't want more. That's okay. We'll talk about it in the next class. But that will be the thing that we're doing. Okay. So let me go to the data again. Okay. Okay. Is that okay? We just draw the data, right? So again, we import a stat model. We call X the distance, Y the price. We add a constant to the X. We declare an OLS regression. We fit the results and print it out and plot it, right? So that's just, I guess so far is something, hopefully not too fast, okay? Because we can't hold your hand for too long, right? At some of the point, we have to jump a little bit. Right? Otherwise, we keep holding your hand, then we will be a little bit too slow. Okay. So once we did that, this is the diagram, and you should expect to see the same, right? So we draw this the same as the book, right? So we're nice, and these are the deal you want to get, right? So that is the book suggests is the best deal, okay, according to the book. Okay. Because they look at the highest vertical distance. Okay, because that is, you want the biggest discount, right? In absolute terms. So that's why they look at the hotel that has the highest distance from the line. Okay. Is that okay? Until now, we answer our first question, how to draw. But of course, you can also apply the same idea to here, right? We have go back to here. We can also find the best deal, right? Is maybe the best deal somewhere like here as well, right? Highest distance, right? This is maybe the best deal, right? And maybe this is also good as well, right? Depends on what model you're using. Okay, but you can see they point to something similar. This between 1 mile, this is a good one, right? Somewhere between 1 mile. But anyway, let's continue our short journey on regression, right? And remember, the regression table has so much stuff here. Okay, and in this class, we don't have time to go over everything, at least at this class, but we'll teach you more for the rest. But we want to talk about is, for today, will be very important metrics. It's called R square. Okay. And this R square will be very important in terms of later you will see we do the fitting. Okay, we do the some kind of learning, then you will be R square with the thing that is measuring how good it fit, right? So far, we didn't say we fit the regression, but we don't know how good is the fit. Okay, so and how fit is the regression is what we call R square. Okay, and to talk about R square, we'll define bunch of this. Okay, and probably you will kill me if I talk about all this formula. So instead of talking about this formula, look at the graph. The graph actually gives you everything. Okay, and the formula is there. Okay, so don't worry. I'm not skipping anything. I just skip the notation. Okay, everything is there. But once you see this, this is very clear. So how do we say how fit the model is? Okay, how good is the regression? So the first thing to say is we want to use X to explain Y. Okay, so we want to explain is variation of Y, right? So what we try to explain is what we call SST, right? We want to say data point how we deviate from the mean, right? Because even if we don't use X, what is our prediction on Y? Just Y bar, just the mean of Y, right? Mean of the Y is the easiest thing to predict, right? To predict Y, right? You ask, right? What's the price for the hotel? It's just total average is the best prediction. You don't tell me the distance, that's the best, right? So you want to say is, want you use X to help our prediction. So SST, the distance from this data point to the mean, you square it, add it all up, is SST, right? So that is the notation we use here, is each observation minus the mean square sum of it is the thing we care. So this is thing, right? So basically it's all the, if you want, will be all the orange thing you square is SST. Maybe I should use blue, right? Because otherwise you will confuse, right? So this basically all the blue thing square add up is called SST. Oh, sorry, this is wrong. All right. So all this is SST. Okay. How good is a model? Our model tells the line y hat. Y hat is a predict, right predict, right? And our model actually explains this variation, right? This our model explain. Model tell us if this is X, this is my Y, right? So our model actually explain this part, right? Or this, the red one is our model have done, right? Our model did that. Sum of square of all this distance is called SSR, right? R square is simply the following: how much we have explained over how much we want to explain. And this must be between 0 and 1. That's a proof, but we are not going to do that. And particularly if R square is 1, every point on the straight line, right? Because SST is the SSR is equal to SST, right? Because all the point on the line, right? There's no difference. And as you can see, the remaining part is unexplained, is SSE, okay? But that would be, there's a formula called SST is SSR plus SST, right? But that would be, okay? So that would be the, okay? That would be the idea. Okay? So that's why R square in our previous example, go back. Oh, I didn't print the result. I should have printed that. Sorry, I should print the result of what we have just run the regression on. We should print the result. Let's print result. I think, do we need summary? Result.summary. Results.summary. So in this particular hotel case, distance explains 15% of price difference, price variation. Okay, so it's okay fit, not so good, but at least making sense, right? The price, at least 50% can be explained by distance. Okay, so this is how fit it is. Okay, and this R square turned out to be very useful later when you try to evaluate. And this AIC and BIC later, you will, when we learn, this is also another measure of how good the model is, but we will not talk about that. And this is also a important measure. Okay, and I don't want to talk about those, but F statistics, okay, also is not, we don't often use it, but I'll give you the what is doing is testing the following. This one is very simple. Remember this number, this number, the first one is asking the null hypothesis alpha equal to 0, right? And this is beta equal to 0, right? And we know that P is happy is 0.00. So we are safely to say that they are rejected, right? Happy, right? And sometimes you want to look at the case where the null hypothesis is not just that separately. We want to say if both of them, they can be 0 at the same time. Okay. So why I want to do that? Because this is more likely to reject than this two, right? So this is usually a minimum requirement, right, to do it first. Okay, because if you can reject this one, usually can reject this one as well. Okay, so that's why we don't even bother this guy, because usually look at this is sufficient, right? Because if this pass, this will pass automatically, right? So but historically people look at this, but these days we don't care that much. Okay, but we still keep there. Okay, and others will be here. We look at the least square. We have number of observation, right? And here with non-robust, which we'll talk about that next class as well. We'll change this to robust, but for the moment we just keep what we have right now. Okay. So these are all almost all, and below probably you can forget about it. It's too complicated. Actually, I never use it. There's some reason you want to use it, but I never use it. Okay. But so that's why I don't want to teach something I actually don't use, right? So there's no point to go over that. But there's some reason I want to use it. Okay. But I don't want to talk about those. Okay. So I have already explained R square, right? Is that, and perhaps not surprisingly, this R square is related to, in theory, if you run correlation coefficient, you take the square is exactly the same as this one. Okay, so that's why this called big R square is the small R square the same. But this is only true when you have only one variable. And usually no one actually one variable these days, right? You have many variables, right? So that's why it's not very useful anyway. I just put it here because the textbook have there, I want to show you. But otherwise it's more or less useless. Okay. And so bear with me for, okay, let's have a break. Okay. Let's have a break, and then we'll come back to this last measure of how good you are getting. Because this MSc and our MSc is the way that we fit model in machine learning as well. And also all the thing is look at the MSc, but we already know SSE, but average is MSc. But anyway, we'll talk about that after the break. Okay. So after that, then we are done with this chapter. Okay. So have a break of 15 minutes, and in case you want to say something, which you maybe want to do your homework, but I just do another one in case you want to do. But have a break. Let's come back in 15 minutes time.你可以明白，如果你找人推风扇方面的东西，他这个方向没有，又没完收入，对吧？重要的，但是 不重要是因为是没有 single variable，那在这里跑就跑 multiple，还有 single 我都不知道为什么输有点，然后一开始 multiple 就好了，为什么 single 对，什么都一样，对，对哦，从没有用，你就教一遍不有浪费大家时间，但是我只能教书教，因为其他课已经教，直接 follow 比较跟你上，跟着那个教程，对对对，明年我要求他换的太多，可以看嘛。我可以有一定程度上的自由，但是我不能一下子挂太大。我真正的内容。不演出这个词，我的也我但是加拿大我还是。哦，这个对，有让人信服。哦，对，哦，这个我看，非常好。没有去过加拿大，对，我读书的时候还是挺好的，加拿大挺好的。我在这，我在瀑布的还有，还有点啊，现在这个大概这样，他们加拿大这样，他们长，还有在网上看，对，还有但是我也是也不我没有，我也他们没有这样的，不好意思，我是可以过去，但是他们不，我们他们过了，然后跑下来，怎么写的话，确实。但是第一的历史是好的吧？因为那个地学是这样的，那个另外一点，那我觉得对对对，加拿大一个地方， 这我不能说我是 B.B.A 的。应该是7个吧。昨天还说小学后来是早上后面早晨布告完之后就晚上到第二天那是 M.Phil 来的不是M.Phil 有的时候还刚刚开始合作上你的这个呀数字里边是有这样总结吧开始跳水超时光就是有点这种感觉会在既然我咱们去如果说这些理解我们没开的时候是它对于水的我有注我都不算老外家的比较他们也解释飞书啊，这个开始啊，是不是推荐我知道如果我是同学，如果我有他，这个我现在是身体好，所以 哦，那这样，那我们今天不是说才好，第一个学的那个，不太能打。错他比较上满这个，但是说他们上满好的是空间，就是好在。这个够一点。好，下来，来，可以说来讲话时间。对呀，别说。还是走。我也都差不多，我到这个反正都挂了，有多少也好，反正就是半到3年了So let's see if you have any question. I guess only 17 people. So far it's okay, I guess. Someone is very happy. Infinity. Maybe this code lab, right? I guess. OS none. Overall, it's okay. I think it's I think overall it's not too fast. I like Friday. Yes, Friday is good. I mean, I talked to some of you that talking about climate in Hong Kong, and then the best time in Hong Kong is October. Okay, it's the best of the time, best of the year. It's not too cold, not too hot. It's good time for hiking. Friday you should hike if you have time. You are not too much busy. You should hike, walk around. There are a lot of hiking trail in Hong Kong. I mean, to try because I think you should try. I mean, that's something if you want to remember is hiking is something that you should do. I mean, this. Oh, that's a good prediction. So that we have a model, try to explain my T-shirt is a prediction of the stock market, right? So someone said, if I wear red, then it's going to be good. My white is going to be bad. It seems to be good correlation. If you try to build a model, probably you can get a right model of that. Yeah, I went for interview on Monday because we don't just match. We don't match just after walking through my CV in demo experience what we're doing. Oh, well, so I think you asked a explanation for economists, okay? So why, if they don't match, they still want to do? Yeah, well, yeah. So this is the same as the question like the following, right? There always some case like a woman who go to a matchmaking meeting, right? And that girl just go 1 minute after the meeting, right? 相亲 right? 就相亲以后马上就走了. So why, right? Because the 相亲 is organized by relatives or friends. Just go and say bye-bye, right? Obviously, it's not going to be interesting. Same as the KPI, right? Because why they want to do a interview is because of they need the procedure. They may have already hired someone, but they cannot just interview one person. They have to interview several persons so that they actually are doing some screening, right? And that is what they want to do, right? And or similarly, right? I think that is the case, right? And I think there's a movie, right? And what they said is how to make friends with girl, right? For a boy, the teaching advice, right? And they saw there's a 3 girls over there, right? So if you want to, you want to know one particular girl, right? So you cannot just go there and talk to the most beautiful girl, say, can I have your number, right? You have to ask for everyone, right? Number, right? And then you just ignore the 2 numbers that you don't need, right? And then you just call the last one that you really want, right? Same as interview, right? You can't really just pick up we just interview this guy, this is your only guy, and that's done, right? I mean, that is not done in this way, right? I mean, you've done it this way, then obviously they're trying to signal something, but this is where it's standard. I mean, unfortunately, this is what happened. I mean, for the procedural thing, they might have already figured out that there are multiple series, then one guy stand out from the rest, but they have to still follow the procedure. It's not this procedural thing, right? Just like more or less like the assignment. I pretty much know you know how to do, but we still have to do it, right? Sorry for that. That is a economist explanation, right? Whether like it or not, that's my story. Okay. So it's similar to you go to a restaurant, right? The waiter and come and say, welcome, or meet anyone, right? These days you say, 你吃了没有? Right? We actually don't care whether that guy eat or not, right? If you go to US, right? They always ask, how are you? And then let's go away, right? You don't really care whether they're good or bad, but you just ask, right? And whatever, okay? So we have SSE. Remember, SSE is how the model is not fit, right? So, and the R square is only meaningful when you talk about regression, right? Because this is a percentage only implied for this kind of model, okay? But the measurement of the SSE, or you look at the average of them MSE divided by M-2, there's some reason why divided by M-2, but we don't want to explain, but just unbiased estimate, like M-1 idea, is underestimate the error, okay? But MSE is the thing that we try to determine how fit are the model, okay? So suppose I want to compare later when we run regression and we do other machine learning approach or various type of regression. And how do we compare how good the model one over the other? It's compare the size of MSE, right? The MSE larger, the worse the case. And also we have the RMSE, the square root of that. This is the way you evaluate your model. Okay. So how do we do calculation? I'm not going to talk about that, but what I'm going to do is later you will see sometimes it's convenient to use another package. We call the skip-learn model. It's basically machine learning model. Okay, there's a package run the regression, and you have X and Y, and then somehow you have to reshape the X, okay, for some special reason, because you want to the matrix, and you fit them, and you predict them, and then you can calculate the mean square, the score, okay, and you can calculate them. So don't worry, we don't need them at the moment because the RMSE is already in your regression output here, right? Because the mean square error, oh, not here. But when we run this, you will see how we can generate that guy. Okay, this is one way to calculate. But when we actually do the machine learning comparison, we'll come back to this again. Okay, I just put here to introduce to you. This is the package to run regression, and we use this package when we later do machine learning. Okay, I just being lazy here, or I just doing earlier first. Okay, so don't worry about this part. We'll talk about this very soon. Okay? Next class. Okay, so at least so far, just to review what we have learned, is we learned 3 different models, right? The first model is called the bin scatter. You just try to divide them into different groups, right? Then the model will be averaged in the group. Okay. The second model we learned is this a very special way to smooth out the regression. It's like basically just the data, the mean, but you smooth out the mean. There's some formula behind, but we don't talk about that. Okay. And the other one, the last one we talk about is the regression align. And we learn in detail how you would want to use it. Okay. But this is the model. We'll talk about how to use it in the next class. But first, we want to know is how to estimate it and how to evaluate based on R squared. Okay. So what we are going to do now is, before we go to multiple regression in the next class, is we do some transformation on data. Okay. And this is often we do some transformation of the model. Okay. And do note that we still use single variable. Okay. So there are many ways to allow nonlinear, because when you look at this diagram, the lowest doesn't seem to be linear, right? You fit a linear line, then doesn't seem to be good, right? It's somewhat like flat here. So is there any way you can fit the model better, or we can do better? Okay. The first thing we often use is to focus on the log. Okay. Log is the way that we do estimation. Okay. When we do prediction, instead of measuring the level, we do the log. Log is very common. Okay. And the reason why log is it capture the percentage difference. If you have data time series, log is the percentage change. Okay. But I don't want to talk too much about that. Okay. So basically, we want to focus on these 4 different regression. Okay. Either I take log on the Y, I take log on the X, and I take okay. I think this typo should be level regression. Okay. So the first one is we have done. Sorry for the typo. And the second one is log the X. The third one is log the Y. And the next one is log everything, right? Only 4 combination. Okay. And so the beta here actually means X changed by 1, Y changed by beta. Okay. But what is this interpretation when we take a log? Okay. If you learn calculus, beta means that if X changed by 1%, Y changed by beta. Okay. When we take log, it means percentage change. This is common with calculus. I'm not going to talk more about that. And for this equation, it means if X changed by 1, Y changed by beta percent. Okay, because this, when you see log, you can in your head percentage change. Okay, that is how you do interpretation. Okay, so how you have a beta. The last one is if there's a 1% change in X, there will be 1% change. So beta percentage in Y. Okay, let me repeat everything because that is so important. Let me sit down because this guy is very difficult to talk. This is also very weird. See, very annoying. So the first beta is if X changed by 1%, Y changed by beta. Okay. And this beta is if X changed by 1, Y will change by beta percent. Okay. And the last one is if X changed by 1%, Y will change by beta percent. Is that okay? Okay, we will show you the example here. Okay. So how to take the log? It's not complicated. We'll do the NP. They call NP.log. Okay. And you run the same thing. I'm not going to do it again because this is nothing new here. Okay. We'll do the exam. We'll do the case study. That will be there. Okay. Okay. So this nothing new, but this is the 2 new thing there. Okay. Log it. So this log model. Okay. And just to remind you, for the log model, that means that if X changed by 1%, Y would change by 0.5%. Okay. So this is the model that we run the regression, all right? And you may want to say, what is the problem for this data? And you will say the main thing is this seems not linear, right? If you try to fit in your head, it seems this non-linear will fit better, all right? So that is something that we're going to try to do, is to take some log and see if this is going to fit better. Okay. So we try to load the data, just copy, because I think by now that shouldn't stop us for the difficulties of this one, right? And we do the filtering. I mean, I just copy it because I don't. This is well known. I just don't do the same. I just do the same. Put it there. And now we do a regression here. Okay. I think I missed the package. Got the package name and stuff like that. Yeah, this is the package. So I need a package here. I don't want to type. Sorry, I forgot to include this one. For some reason, it's missing in my slide. So, stat model have many ways to call it. Okay, and what we would do is to use this formula API, because inputting formula is easier. Okay, instead of y and x. Okay, so we will do stat model formula using OS, and this is the y, this is the x. Okay, and this will make our life easier. Okay, and these are the column names. Okay, and you run it, you feed it, then you run the summary. Okay, so this is maybe I should just print summary, it's better. So this is same as before. Okay, so sorry for missing this in your slide, so please add them back to your model. Okay, this is the model we want. Okay, is that okay? So the data is there, but the data I think is already there already. So this is a regression one. Okay, is that okay? So now we do the prediction because I want to draw a graph. Okay, so I call this x and y. Okay, so what I do is I call x and y, and the y predict is based on the data I predict, right? So this is the prediction. Okay, and then the same thing, I do the scatter plot. This is the same code as before. Okay, and you may ask why I do this formula. Because the formula will be more general. Okay, will be more convenient. Okay, so this is the regression. Okay. Maybe the dot I have size of 2. Okay. So this is the regression. Okay. I forgot to run this line, so that's why it's different. I should run this again. Sorry. I should run the regression again. Okay. So this is the regression we got. Okay. So there's nothing new, but we do it before the break. Another code, right? Because the new thing we learn is to run this through this new code, which I think is easier. And you may ask why I do this. Sometimes I do the other way around, because you will use both. Okay. You will notice that these two are useful, so that's why I do that. Okay, it's the formula style. Is that okay? If that's okay, then we do the log. So I think it will be fun to do the log thing. Okay, I take log on the wise log level model. So what I'm going to do is, it's very simple. I create a new column called log price, which I do MP dot log the price. Okay. And this is the regression tool is I run over different y and the same x. Okay. And I can plot it. Okay. And see how good it is, right? So let me run this. Okay. Now let me run it and slowly and go over with you what I will check when run regression. So this is the log, and I take the regression, and I also print a summary. Okay. And once you look at this, then you check the p-value are all 0, so it's very happy, right? That R square actually is better, right? Actually a better fit, right? Because remember, the R square in the original case is 15%, right? Now the log actually we explain 60%, so 20%, right? So the distance is nonlinear, right? So that's why this is not fit much better, right? So if you try to do the plotting, let's do the plotting. Run this code. Do the plotting there, just copy the code. Do the plot. Right? You will see that this actually a better fit, right? But of course, the meaning is different, right? Because now we are not saying that, remember this original regression. This beta means that if my distance is 1 mile closer to the city center, the price on average dropped by $14, right? That is what this mean in the linear case, level. But when I have log level, I have this negative 0.13. What does that mean? It means that if I go to the city center by 1 mile, right? The price, okay, would drop by 13%, right? It's 0.13, right? So that would be the way that you would say, right? Is that okay? So you drop by 13% if you go closer and closer. Now, if you do the level log, that would be something similar, right? As I said, you would do the following, okay? There is some tricky part actually in your regression. There's some minor thing that I want to do. Actually, the book would suggest is, okay, you attempt to do only this part and you're done, right? You just take the log on X and then it's okay, okay? But the problem is their hotel exactly the city center, then the distance is 0. Log of 0 or close to 0 is a very big number, okay? So what we're going to do is to replace anything that is so small, close 0.0 mile to 0.05. So basically it's like what we call the sensor from below, right? Anything less than 0.05 replaced by 0.05. So that's what they do is distance 2, so that less than 0.05 replaced by 0.05, and then take a log. So that's a little bit tricky part here because otherwise your model will be very unstable. Okay, you don't do this in price because the price is always more than 100, right? So there's no price near 0. So you don't need to worry about this. So there's some little bit complication here, right? Because when you take log, you have to make sure that these things doesn't happen. Otherwise, your model will become crazy. Okay, so that's why when you take log, have to be very careful. So, okay, so this is regression free. Okay. So you can print that out. Okay. So this will give you this diagram, right? So what does that mean here? The p-value are all 0, then you're happy. Crosswing. The second thing is actually even better, right? This is 28% of the data being explained. Okay, so it means that the price is respond to percentage in distance. All right. So this means that when it is very close, right, the change in distance will be very large, right? When it changes from 0.05 mile to 0.07, then it's a large change, right? When closer to the city center, the price change a lot, right? When you're far away, little far away is not that much. I think it makes sense, right? When you're far away, you can drive, right? So in that case, that is reasonable. And you can see that it means that if you have 1% change in the distance, the price will drop by $24. Right? So that is what it means. Right? Okay. And you can plot the graph. I'm not going to plot it, but you can see this is the that is the model we have, right? The last one, take log on both sides. Okay, you can do the same, but I'm not going to do it. But that would be trivial, right? But I think we still want to do that because I want to show you the fit, right? We don't do the plotting, but we just still do this particular print out and see how fit is this model. Okay, and this even better, right? Look at R square, jump from 28 to 33.33, right? So 33%. So basically, right, it's not about the absolute value, right? Rather than change in percentage in distance, it's a change in prices percentage, right? And the interpretation is like, right, when you distance increase by 1%, the price will increase by 0.2%. So that would be the model that fit the best. Okay, so you can see even though I run a simple regression, it really depends on the form. Okay, and probably the question in your mind is, I have 4 models and which model is used. But if you have to choose one of the 4, one thing to do is look at R square, right? Or later you see the MSE, right? If I have to pick, I will pick the last one. Okay. But later you will see when we talk about prediction, log may not be good because the interval actually can be wider. But we'll talk about this later. You may really want to use it, but if you look at R square, that may be the last model, this one you pick. Okay, and this is the summary of this model, right? We have that. Okay, I don't think this is super important. Okay, and here I want to introduce you something that is very good package. Is called star glazer. Okay, star glazer is trying to get star. Okay, not the star on the sky, but star on the regression. Okay, in the old days, because when you look at regression table, they always put star when the p-value is less than 5%, and your 3 star is p less than 5%. 2 star, when you have 1 star, when the p-value is less than 10%, 2 star is more than less than 5%, and 3 star is less than 1%. And that's why we always want star. Okay, we want star, then your job is over. Okay? Your job is done. Okay, so here is, if you learn Python, you know the P type install is the way you install, right? So in order to install it in the code lab, you have to use this particular command. Put a exclamation mark. I don't know why, but this is, they do it. So you do it, and it will go to the website and do the installation. Okay. It will take one minute. It will take 4 seconds. And once you've done this, why we do this? Because we want to combine the 4 regression in the same thing. Okay. So what we need is, the code is very weird. It will be from Star Glazer library and Star Glazer sub-library. You import the capital letter Star Glazer. I don't know why that's crazy, but anyway. But just you just need the first 2 lines. The rest just make it look nicer. So let's do this line first. Okay. Actually, you just need to this line. Okay. Now I don't even need that. I just need that one, right? So I don't even need that. But this is the one I need. So this is usually what you see in all the academic research. It's a table, the nice form, with all the star, right? And so this is the table that usually you observe, and then that's the table we like, right? R square is here. You can see that the last one is better. Okay. Okay, so this is the model. Okay, and you look at all this crazy row is to make it look nicer. Okay, the first one is to say I usually don't care about intercept, so I reorder them. So if I do that, okay, then it will get reorder, right? So I do that, and I do that. Okay. Then you will reorder these rows, right? You start the distance first and then intercept at the end. Okay. And you can see the other row are similar. So this, I would put this, I want the column because the Y are different, right? So that's why I put this line there. Then you will be telling me that what the columns are, right? Because column are price, not price, price, price. Okay. And 1111 means this is only, this apply to the first column, this apply to one column Y. Okay. And you also want to rename it, right? Intercept is constant, and you make the new name that's called rename covariate, right? So you don't have to use it, but in case make you happier, okay, then you can use it. Okay. And this will make your model very professional, looks like exactly what you see in the book. Okay, so that is where professionally model actually can put in your put in the report directly. So this is very standard when we run regression. Okay. And beneath it a lot, running regression is a job. Okay. And in the US, actually, especially when PhD like econ PhD like me, I mean, I have many classmates actually running regression for life. Okay, they make a lot of money just running regression. In the US, because of a lot of policy need to run regression to evaluate how good they are. So suppose government do some policy, before they do it, they need to do a study, and government pay them to do it. Okay, and because of different policy and by different party, they want to put forward, and they will hire people to do public work. They do all the regression all the time, and in China, there are also a lot of jobs like this as well. But I know that you guys are going to make a lot of money not doing this kind of cheap job, maybe you call, compared to IT. So, but in any case, if you know how to run regression already, you can do it. A lot of jobs can be done based on running regression. But anyway, I guess the explanation. Okay. And this gives you explanation why what are this. So I don't think I need to explain. Okay. I don't have the fun time to finish all of them, but I want to give you this guy. Okay. This guy is way closer to the bean scatter plot idea, right? Bean scatter plot is divide them into multiple groups and you calculate the mean, right? So if you remember what we have, the spin scatter is like this, right? There's some scatter plot here. Okay, this is data, right? So spin scatter plot is mean I cut it into these different pieces, right? And I try to look at what is the average value of here, average value of here, and average value of here, right? And why don't I call this regression as well, right? Can I do the same regression here? Is similar ideas. I cut this data into half, right? And I fit a regression line here, and I fit a regression line here. I have a regression line by line. Okay, so that would be the goal of what we're doing. Okay, so let's quickly go to this one because we don't do any proof. So basically is I would try to do a regression line by line. Okay, and then they will connect it. At the end, it will look like I don't have graph. Should be something like this. I have a regression. This cut is here. I run a regression and another regression. Okay, and of course, you try to move this up and down, move this up and down until this is the vertical distance minimized. Okay, so that is the idea, and the way that we run this, we'll talk about this next class, but we'll use the BS, okay, BS function, okay, basis. So I have the spine basis, okay, and it depends on where I cut it. So I cut at 2.5 and 3.5. The knot is where we stop to have breaks, okay, because I run the regression. I just here I cut, and these are the knots. Okay, and once I do that, it's a linear because a linear slide. So then I just include them and run the regression, right? And I just the basis is the spine. Once I do that, I can run the same thing. I get the piecewise linear. Okay, but I will talk about that in the next class, and then I also would talk about how to include the square term there. But otherwise, everything looks similar because we'll give you another case study about the life expectancy and GDP and try to fit the data to you, and then we'll do multiple regression. Okay, so if you are the first time to learn this, that will be, if you forget, that will be something difficult. But don't worry, we'll go slowly to make sure that everyone has a solid understanding of regression, because this part is the most important thing in the model in the class, right? Because after this, then is machine learning model, right? So, but don't worry, we'll come back to this one again. So the only thing you need to remember today, I guess, is we learn how to run regressions, right? And the way you can transform the variable and run the regression again, okay? And the transformation of log is whether you like it or not, then sometimes you can increase R square. But once you do that, the interpretation is different, right? It's not, say in this case, say suppose you like the last model, then it's not about the distance and the price, but rather percentage in distance and percentage in price, right? So that you change the things you're predicting. Okay, and then in that case, it's unclear whether you're finding a best deal, right? It's not clear whether how can you find the best deal, right? Because when you have a linear model, right, you can easily find the best deal by looking at this guy, right? But when you try to look at this log model, say, it's like log model, looks good, but no longer I can't easily see which hotel is the best deal for me, right? It's not clear, no longer very clear. We'll talk about some way to make it clear, but at the moment it's not clear how to do it. And that's why we are not blindly looking up best R squared. Okay. This is good if you want to do prediction, right? If I say, what is the price of this hotel? You want to do the prediction, you use this model. But if I want to find the best deal, this is not a good model. Okay? So the goal is determine what thing you want to do, right? If you want to just predict what is the right best deal, use the original form you want to do. But if you want to do some prediction, right? Then this is the right model. Okay. But I should end here. Then I will have a good fun on Friday. Assignment 1 has been released, so let's try to do it. But if we talk, as I said, some of you already finished, then you can't have fun on the Friday, but hopefully you will happy when I see you next time. You can see the assignment is very simple.